Okay, all right, students. So welcome back into the next lecture of the algorithmic series we have been discussing so far. Now we will shift our concentration on different strategies for designing an algorithm because a single solution for a problem P will not fit as a solution for all the problems. So if there are n number of problems, so one solution to all those problems will not be possible. So we need different strategies to build up an algorithm based upon the type of problem we are facing. And these are the different kinds of algorithms strategies which are available. And first and the foremost is the greedy approach which we'll be dealing. So to illustrate this point, suppose there is a person P or it is a problem P in which a person has to go from a place A to place B. So there are multiple solutions for solving this problem. The person can either find a solution S1 by walking from this city A to city B. That could be one solution S1 for this problem at hand. The another solution could be S2, while the same problem could be solved by driving from city A to city B. Similarly, a person can take train and he will again reach from in between the two cities, and that will also become a new solution S3. And somebody else can come up with some S4 solution in which he can also travel in between these two cities using ear as a medium. So for a single problem, there are different solutions possible. And all those solutions which exist there for a single problem. These are solutions are known as feasible solutions to a problem because any one of those solutions is a solution to our problem, that is to move or to shift from A to B. So all those solutions from S1 to S4 will become the feasible solution for the problem P. But if there is now a constraint given, so if there is now a constraint given in the problem itself, that you have to travel from A to B, okay, that's clear. But the time is also given that it should take only this much of time for you to travel in between the two cities. So if it is in between Gandhinagar or Ahmedabad or Delhi, so now the timing is also given that it should take only 2 hours. In the previous case, S1 to S4 were all the solutions and they become feasible. But now when a condition is given, when a constraint is also given, that the time it should take for you from A to B should be only 2 hours. So the solution among those pool of solutions from S1 to S4, which will satisfy this constraint, that will be the optimal solution. That means a particular problem could be having multiple number of feasible solutions, like in this case. But a same problem could be having only one optimal solution. And optimal solution comes into picture when there is a kind of optimization in the problem. Optimization means either You have to find a maximum value of something, or you have to find minimum value of something. Here we are find the minimum value. It should take minimum amount of time for you to reach from A to B. When the minimum comes into picture, it is an optimization problem. And whenever there is an optimization problem, we use greedy approach to solve such problems. An optimal solution is itself a feasible solution. It is both a feasible solution plus it is also satisfying the conditions which are associated with every problem statement. And this is the case of minimization, but there could be the case of maximization also. Like we are being given a problem and the corresponding properties are associated with all tasks. And we are being asked to find a solution which will be both a feasible and will also produce the maximum profit. So at that very time, it will be again an optimization problem, but of maximization quality or maximization flavor in it. So such type of problems where we have to either minimize something or maximize something, those are being solved by a spatial approach that's a greedy. And greedy word itself means what it sounds. The greediness is in the approach itself. So we at a particular step when we solve a task, we take greediness into consideration. Greediness means what is best for me at this time. I don't care whether it will be best in future or not. But what is best for me at the present time, I take it. Okay. So what is best for me? What is best for the problem as a solution? I just take it in the greedy approach. And when this means that I am focused on local optimization. Local optimization means what is best for me at the present moment. At time t is equal to 4 seconds, this is the best for me. So let me take it. I had to go from here to Delhi. So if I don't have a convenience, I will, whatever is best for me from here, Gandhinagar to some nearby state, I will take. After reaching to that city, whatever will be best for me, I will take that. So this becomes a local optimization, local optimization, local optimization so many times until this combination of all those local optimization finally becomes a global optimization for the problem. And the algorithm is given on the right side. A solution is initialized in a variable, or maybe it could be any a kind of data structure which contains the solution is already found for the problem. Then we take a looping statement and we find all the feasible solutions, means all the solutions which will solve this problem which is at hand. And if that is feasible, feasible means again which will be finding the solution to the given problem. We add those list of feasible solutions inside the previously declared variable solution by making a union with all those solutions which are solving this problem, means S1, S2, S3, S4. So the condition where this feasible solution does not solve, those will be eradicated. So greedy algorithm, some more definitions before we will land into an actual example which will make us clear how it is able to solve the problem. So as I said, our idea is to find a solution to a problem in an optimal way, either to maximize something or to minimize something. And this algorithm will contain both the two types of items. One will be the items which won't be in the list of feasible solutions. So firstly, we had to find which solutions are feasible. which will become a part of solution, then which one out of them is the best? And the remaining ones which does not come under the list of feasible solution either, though they don't have any effect or any part to play in this algorithm. Similarly, the structure of the greedy algorithm is that initially we choose a set of items which we declare as a solution set. Then we go to eat for loop as given in the previous pseudocode. This item will be added to this solution set, means this will become a feasible solution to this solution set which is already declared if it satisfies those solution properties. If it contains the solution to the original task, then it becomes a part of the solution set. Otherwise, it's no longer a feasible solution. Because if it is not solving the problem by either means this is not feasible, and the one which is not feasible, that won't be optimal also. Okay. And always a greedy strategy of designing the algorithms starts from top and goes to bottom. It's a top-down approach because of the logic it follows. We go by taking a particular step which is best for us, then we go to the second lowest level and take the local optimization step also, which is best in that case. But similarly, we keep on doing this greediness at each step, greediness at each step, greediness at each step, until and unless we reach to a bottom stage where we have to reach. Okay, these all theoretical part associated with greedy algorithms will come. It will get all clear if we take an example. And this is the first example of this greedy approach. It's known as knapsack problem. The first algorithm which we'll be studying, it comes under the greedy design strategy. So the knapsack means we can say a bag, any container in which something can be loaded. Maybe the books, the money, any items can be loaded inside this container or bag. And the knapsack problem says that there is a thief. The thief has to stole something. It has to stole some items, maybe n number of items. But since it is a greedy approach, means there will be some optimization problem. And the optimization conditions are that the weight of the items which he is taking or stealing, that shouldn't be greater than a particular weight m. So all the items which he takes, if we add their weights w1 plus w2, that shouldn't be greater than m. It should be less than or equal to m, means a particular weight is given which could be occupied in that bag, not more than that. First condition. And the second condition is that every item is having a profit associated with it. Item 1 is having some profit P1, item 2 is having some profit P2. He has to select the items in that order so that the whole sum of the weights of all those items should not be more than m, and the profit should be the maximum. So there are two conditions associated with this thief. So this means the thief does not have to be only a thief, but he has to be a clever thief to solve such optimization problem. And for the knapsack problem, there are two variants for this problem. The first one is the fractional knapsack. Fractional knapsack means the thief can take even the fractional part of the item. He can, it's not necessary that he will take always 1, 2 in decimal. He can also take fractional, a sub part of the original part. Like he is stealing the money from the bank, so it's not necessary he can only take 2000 notes. He can also take the change in terms of 1, 2, 5, 8, 10 rupees. Or you can also take the example that he is stealing the vegetables. Okay, so it's not necessary he will always take. There are there is one item, that's the potatoes, and the potato is hang 10 kgs. So he has to take all the 10 kgs. Now, so depending upon his need, he can take only 2 kgs from that, or even 1.5 kg. That's why this type of knapsack is known as fractional. And remember it, fractional knapsack is solved using greedy approach. But there is another version or variant of this knapsack that is not fractional, that is the integer. Integer knapsack means we can't take subparts, we have to take whole item. If we had to steal those tables, we can't divide it into three. So the thief has to take either whole table or has to leave this one and go to item number 2. This becomes the integer knapsack, and it is being solved by another design strategy, but not by greedy method. So we will jump more into this knapsack problem. So I said knapsack problem is a container loading, we can say it, and we can take parts of the items, but not whole the parts. So to illustrate it more, we will go here and we will see what this problem actually says. The problem says that we are hanging some objects. These are objects here denoted by O. Then profits and weights are associated. This is profit, and every object is associated with a weight. 1, 2, 3 objects are given here. Okay, so the thief has to steal 3 objects. The profit is 25, 24, and 15. 25, 24, and 15. So the object number 1, if he steals, he will get a profit of 25. If he steals 2, he will get 24. But it's not only the profit, the weights are also given 18, 15, and 10. 18, 15, and 10. These are the corresponding weights associated with every item which he has to steal. Now, the total weight in the bag, in the knapsack, N means the total number of items, which are 3, and M stands for the total number of weight that could be present or that could be loaded inside this container. That's 20 in the present case. Is it clear? So we can load 3 items, only 3 items are there, and the total weight should be in the container either less than or equal to 20, but not more than. Okay, so we can come up with some guesses. We can come up with some guesses. The guesses are like, if I draw it here below, the guess number first could be that we will denote it item number 1 means we are taking, this is item number 2, x2, this is item number 3. And this we denote as the solution number first, which is the solution for the problem. And we will say that we will take half, 1/3, and 1/4 because this is fractional. Half, 1/3, and 1/4. So that means we will take half from this item number 1, half. If we take half from item number 1, I will write it here. So if I write it here profit, here I will write weight. Okay. So when I take half from item 1, it means I am taking how much weight? 9, because it is hang 18 as its weight. I am taking only half of that, so I am taking 9 kgs. Similarly, I am taking half profit then also. Isn't that? So then I am taking it 12.5. But I am comparing this weight with this weight, which is the total weight, which is the condition. That is it bigger than? If it is bigger, I have to then decrease it again. I have to take even lesser than that. Since it is lower than or equal to 20, the condition is true. So yes, I can take this much as far as this solution is concerned. Now, this is for x1. So similarly, I go to x2. X2, I am saying I will take 1 by 3. 1 by 3 means I am taking profit equal to 8. Profit I am dividing into 3 parts. Yes. And similarly, I am taking weight equal to 5 kgs. And again, I will check that the weight I have taken, which I will denote by load, that will be this one plus this one, 9 plus 5, that is 14. Is that less than or equal to 20? Yes. So I can still load some more into my bag. So I will take item 3, x3. So while taking x3, I am taking it 1 by 4th. 1 by 4th means I am taking profit equal to 15 by 4. Okay. That will become equal to, and similarly I am taking its weight equal to 2 point. Now if I find the total profit in this case, the total profit will be how much? It will be 24 point something. Suppose we will take it as this much. So this random guess that I will take, the thief is not so clever. So what he says, I will take half from it, 1/3 by it, 1/4 by it. Okay. And he gets a profit of 24, but he thinks that he has got the maximum profit because of his own logic. But some other thief comes and he says, no, let me take some another random guess. That is thief number 2. So x1, x2, x3. Let's see what he thinks, how he solves this problem. He thinks, let me take x1 is equal to 1, x2 is equal to 2 by 15, and x3 is equal to 0. So I will again draw for x1, x2, x3, p, and weight. So when the second thief comes, he says, let me not take half of the first item. Let me take it whole. So its profit will be equal to 25 and weight will be equal to 18. So now I am having only 2 kgs left to be filled inside the bag. So he goes to item number 2, x2. And he says, let me take its 2 by 15th of the fraction. Okay. 2 by 15th of how much? 15. That will become 2 kgs. So that it will become 20. And similarly, 2 by 15th of 24. That will become how much? Okay, let's write it. So for x2, it will become this. x3, he does not take anything because already 20 kg is filled. So the total profit he will earn at this time will be 28 point something. Okay. And similarly, without drawing all those conclusions, we will now go to the person or the thief who is the third thief in the list. The third thief says that let me take item number 1 x1 equal to 0, take x3 equal to 1 as a whole. So he will earn 15 for this and 10 kgs will be settled there, 10 are already added. So he takes the remaining 10 kgs from the item number 2, x2. 2 by 3 of 15, 3 5s are 5 2s are 10. So he takes the remaining 10 kgs from X2, and similarly he gets a profit, and when we calculate his profit he gets it 31. So this is a little more clever than the previous thieves. Okay, now the fourth thief comes and he says, no, let me do in some other way. Let me take x1 0, let me take x2 as a whole, and let me take half of the x3. Okay, so x2, this is the fourth one, fourth thief. The fourth thief says what? Let me take x1 equal to 0. So no profit, no weight. Let me take x2 as a whole. So the profit will be 24 and weight will be 15. And let me take this x3 as half. So weight will be half here, 10 divided by 2, that will 5, and that will add up to 20. And the half weight will be how much? 7 point. If I found the profit here, it will be 31.5, which is the maximum among all those thieves. So does it mean since all those solutions which we found, from thief first to thief second to thief third to thief four, these all are the feasible solutions? Okay, these all are the feasible solutions, but what we need is the optimal, the one which will be the best among it. So if we'll be having a problem like this, but we'll be having thousands of examples, does it mean we have to repeat all those examples and then compare each other and find which one is the best? No. Those are the situations where this greedy problem comes into picture. So instead of taking this random guess of first thief, then second thief, then third thief, then fourth, fifth, sixth, then comparing their respective profits with each other, we come that we have to take this much of first object, that much of second object, then the one which is best, we will see this one we have to take. No, the greedy approach is here where it comes into picture. Now, what greedy approach says that instead of thinking which item is having maximum profit, because we can say since we have to increase the profit, so here we will go to this row number 2 and we will see which item is having maximum profit. So it is item number x1, 25. Okay, and we will start the item which is having maximum profit, then the item which is having second maximum profit. This could be also one logic. The another logic is the person will come here and he will say, since we had to insert the items with less weight, I mean the weight is given to us, it should not be more than 10, 20. So let's start by inserting the item whose weight is lower than all the other items. Then start adding the next weight which is little bit more than the lowest one. But this way it won't be also a feasible solution. The feasible solution will be to compute a new term, which is the ratio of both. That's profit divided by weight, P divided by W. Per kg of weight, how much profit we earn. This will be the good term to calculate. So when I calculate profit by W of these, so this will become 25 by 18 for item X1, and that will be 1.38. So that means for 1 kg, item number 1 gives me 1.38 of the profit by weight term. For item X2, it is 24 divided by 15. That is 1.6. So its profit by weight is more than the item number first. Then item number third is 15 by 10. That's 1.5. Okay. Now I will start. The greedy algorithm says that add the items in the bag in the order, the one which is having the maximum P by W value, that should be added in the container or bag initially. Okay, so again, if I try to solve it here, This is x1, x1, x2, x3. And the term I am calculating is profit by weight. For this, it's 1.5. For this, it's 1.6. And for this, it's 1.3. Okay, 3. So the greediness tells us that the item whose P by W is highest in the group should be added into the container first. So X2 will be added, and how it will be added, that will be defined by its weight. Since X2 is having the weight of 15, and I know the maximum I can put inside the bag is 20. So x2 I can put as a whole. Whole means x2 is equal to 1. This is what it means. When we put whole the item, we write x2 is equal to 1. That we are putting whole item in the bag. We are not taking its fraction. So x2 profit weight, I am taking it whole means 15, and its profit is equal to 24. Okay. So out of 20 kgs, 15 have been loaded. Now how much is left? 5. So I have to see the turn of the next item, which is having the maximum profit by weight. And who is that? Item X3. So I will go to item X3. Item X3 is here, and X3 is having profit of 15 and weight of 10. But since I can load only 5 more kgs, okay? Since I can load only 5 more kgs inside the bag, 15 have been already loaded. So from this item X3, I can take X3, then equal to weight will be its half. Similarly, this will be its half. And that half will be again equal to how much? 7.5, because the total profit this is having is 15. And the total weight is 10, because I had to take only 5 kgs. That will be half of it. So it will be equal to 5 kgs. And this 15 plus 5 will be equal to 20. So it means when I see the next item who is having the next highest profit by weight, which is item number X1, I can't be able to add it because already my bag is loaded with the highest amount of it can be able to store. So my profit will be equal to 21.5. So here in the previous cases, we had to take so many random steps, then compare with each other, and then we reach to a stage where we are, after comparison, coming to conclusion that this is the highest profit which I will earn, and all those solutions are feasible. This one is the optimal. Here, by using the greedy approach, I don't have to drive myself in the pool. I have to just use the greediness, and I am able to find the maximum profit. Now, we need to see if we need to see whether it is satisfying these two constraints, because every greedy problem is attached or having the constraints attached with it. The constraints are two. That's the total weight of the items, Wi into Xi. The total weight of the items which are added inside the bag should be either equal to M or less than, and M is 20 here. And that could be proved directly by taking the items. Here we have taken X2 is equal to 1 item. So this 1 will be multiplied by its weight, 1 into 15. Because we have taken X2. This is the solution now, last one in the red. So if we start Xi, Wi, Xi, this means it will start initially from 0. Okay? It will become W0, X0. No, it will start from 1. It will become W1, X1. W1 means weight of the first item. X1 means it's how many times we took it. Since we took it 0 times, so this will become 0. Plus, this summation will get open up. This will become W2, X2, means the weight of the second item, that's X2, and how many times we took it. Since we took it whole, means 1 into its weight, that is 15. Plus, W2, W3, X3. That is the times we took X3, that's half, and it is weight, that will be 5. So 15 plus 5, that is less than or equal to M. Yes, condition number 1 is satisfied. The condition number 2, which is our objective. Objective is to maximize the corresponding profit. So since we did not take X1, we took X2, and X2 we took as a whole, means 1 into its profit, 24. Plus, this is also summation. Then it will be X3. X3 is 1 by 2 into its profit, that is 15, 7.5. That will become equal to 31 point. Now, this is the example now. Instead of taking so many random steps, we will directly take what the knapsack greedy algorithm actually tries to make us understand. So now, that is the total weight which could be added inside the container is 15, either less than or equal to. And what are the constraints associated with it? Definitely the constraints are that the weight which are added of the items in the bag should not be greater than M, and the profit associated with all the added items should be the maximum. So item 1 to 7 are given, and their corresponding profits and weights are also given here in the table. So without taking the random guesses, we will just calculate the profit divided by weight. So for per kg of the weight, how much profit it generates? The one which is generating more profit per kg of the weight, that will be of the highest priority to be added in the list. That this is best for me at the present moment, let me take it. Yes. So when I calculate profit P divided by weight, for item number 1, it is 10 divided by 2, that is 5. For item number 2, it is 5 divided by 3, that is 1.3. 15 divided by 5, that is 3. 7 divided by 7, that is 1. 6 divided by 1, that's 6. So what does it mean? That the item number 5, only its 1 kg is giving me 6 profit is 6. So if I take only its 1 kg, it gives me highest. So this is the idea actually. Yes, less weight and more profit it produces. Similarly, the item number X6, 18 divided by 4 and 3 divided by 1. So when I find their profit by weight, this is 5, 1.3316. So the one which is having highest profit by weight is X5, whose P by VW is 6. Let me highlight it by red color. Because among whole of this column is the item X5 who will generate more profit to me per kg of its introduction into the bag. So I will take X5 initially and I will take it as a whole. Why? Because it is only 1 kg and I can add 15 kgs at total. So here is this bag 15 kg, and when I add X5 into it, so it will become 15 minus 1, 14 kgs I can settle add inside it. Okay, and let me also highlight it by red color. That means this step is over. Now again I will go to profit by weight and I will see which item is having the next P by W, and I realize that it is 5, which is for item number X1. So the thief will start adding X1 into its bag, and the weight which this X1 is having is 2 kgs. So I can add 14 kgs still in my bag. So I can add whole of this X1, and from 14, after adding X1, I can subtract this 2 more also, means 12 kgs I can still add. Now, in the same case, the next highest P by W, and that is for the item number X6. And you see, whatever the item I added, x6, this x5, I write x5 is equal to 1, which means I took it as a whole. X1 is equal to 1, I took it as a whole. Now the next highest is x6, okay? x6. x6 is having P by W 4.5 and its profit is 18 and weight is 4. So I will compare its weight with how much I can still enter. That is still 12. So yes, it is less than, condition is true. So I can enter it as a whole because its weight is lower than the weight of the container now. So 12 minus its weight is 4. Okay. So it means again in the next step, 8 more kgs can be still added inside this bag. Now I had to see among those items which one can be now added. Since the next turn is of the 3 and of the 3 here, so I can add any one of them. It's up to me. So let me add this x3. Both are having the P by W3. So let me add x3, this one. And when I add x3, I see its weight is 5. And I am having 8 kg remaining in my bag. So again, I can add it as a whole. That's why x3 is equal to 1. Means I can add this whole item. So when I add this whole item, I will subtract its weight from the weight of the container. Already it was 8. Now I am adding 3 kg little vacant. Yes, when 3 kgs are vacant, so I will see who is having the next P by W. Definitely it is this 3 now. It is this 3. So when it is this 3, that's item X7, I will see how much it is its weight, only 1 kg. So I will subtract that 1 kg from 3, so it will become 2 kgs. So I can add 2 more kgs based upon who is having the next turn in the list in terms of by profit by weight. So only 2 items are remaining. X4 is having P by W 1, X2 is having 1.3. So the biggest is X2. But still I can't add, its weight is 3. But I can add only 2, so I can take its fraction, 2 by third. 2 by third of third. 2 by 3 of 3, that will become 2 kgs. Yes? And finally, the condition is satisfied that I have been able to add 15 kgs inside the bag by taking the greediness approach into consideration. Okay, this is here. Now, again, I will calculate the same two terms, that is weight. Weight is equal to Wi into Xi. Okay, summation. So I will start from 1. So item number 1. Item number 1, we are taking whole. Isn't that? X1, we are taking whole. That's why I have mentioned 1 here. So it will be 1 into its corresponding weight. That's 2. 1 into 2 plus item number 2. Then I will become 2. So for item number 2, I am taking it fractions into 2 by 3. 2 by 3 into what is the total weight of this item? That is 3. This 3 plus it will become x3. X3 we are taking whole plus x4 we are taking 0 into its weight 7 kg. That will again become 0 plus x5 we are taking whole means 1 plus into its weight, that is 1. 1 into 1 plus x6 we are taking whole, that's x6 is equal to 1 means 1 into its weight, that is 4. 1 into 4 plus x7 we are taking whole, that is 1 into its weight, that is again 1. And when we solve this equation, it comes out to be 15. Means the condition 1 is satisfied. And now we will calculate the profit, which is being attained by following this greedy approach. The profit will be again the summation of xi pi. So again, we will start from x1. We are taking it whole, means 1 into its profit, means 10 plus Here we are taking its 2/3 of part into the total profit, that is 5 into 5 plus here we are taking its whole part 1 into its profit, that is 15. X4 is 0, so it will be 0. X5 we are taking whole part 1 into its profit, that's 6 plus X6 we are taking whole, that is again equal to 1 into its profit, that's 18 plus X7 we are taking 1 into its profit, that is 3, and this is equal to 54, which is the maximum profit among all the items the thief will be taking. So you are having 7 items, you can take 7 any of the combinations, 7 multiple number of combinations of item 7. But you will never be able to beat this greedy method. This will be the highest profit the thief will earn. Okay. So there is this algorithm for this greedy search, sorry, for this knapsack problem, that how this problem is working. So we will go directly to the last slide of this thing. Okay. So what is happening here is that initially a load variable is assigned the value 0, means no item has been added inside the container. And then for a while loop is executed, and this load, that its weight is compared with the total weight of the system. Okay. And the number of items is compared with the total number of items to be added inside the bag. It should be either less than or equal to n. Means if the condition gets satisfied, if the bag gets loaded by only 2 items and there are 3 items, either we can take all the 3 or we can take only 2 if it produces maximum profit. So I should be either less than or equal to n. Now do again a loop statement, but then a condition is checked, and what condition is, if wi less than or equal to w minus load. So the load will be updated at each step, and when we calculate the new load, means the new amount of the weight we can still add in bag. As we saw in the example, initially it was 15 kgs. Then when we loaded 3 more kgs, so now the new weight will become 12. So we are comparing this wi. Wi means the new item which we are adding. If it is either equal to or less than, but from what? 15 minus 3. Total weight minus what load we have already added. The remaining load we can add. Then take all of the item I. So if it is less than or equal to it, this item which we are taking into consideration at the present moment, take whole of it if it is satisfying this condition. Else, if it is not satisfying this condition, which means we can't take whole of it, so take fraction of it. Okay, then take fraction of it until it satisfies this. Add what was taken to load and the amount of weight which we took here, the amount of weight which we took in this step, keep on adding that inside the load, so that this load will give an idea how much we have inserted into bag, and that will satisfy the condition that this load should be less than weight. Okay, and keep on incrementing I plus 1, means the items, item 1, item 2, item 3, until it reaches to all the items. And this is about the fractional knapsack, and we will stop here and we discuss the remaining portion in the next lectures. So anybody among you who understood? Okay, good. The online people, are you able to understand what is going on inside here?
Yes, sir.
Yeah. Okay, okay, okay. Then we can end it here.